Welcome to Chapter 11, Solutions and Colloids. We'll actually be spending practically the whole chapter talking about solutions. We'll mention colloids at the very end, but we're going to spend most of the time talking about solutions. Which then begs the question, what is a solution? What exactly are we going to be talking about in this chapter? Well, to answer that question, we have our definition that we're going to be using here. A solution is a homogeneous mixture of two or more substances or components. So you have to have at least two things, and they have to be homogeneously mixed, which is to say that they have to be completely mixed up. The entire sample is the same throughout. There's not one region that's different than another. As long as those two things are true, as long as you have at least two things together and they are homogeneously mixed together, that is a solution. We actually don't care about anything else. We don't care about what the things are made of, what phase they're in, what temperature they are, anything like that. If we have two things homogeneously mixed together, that is a solution. So in every solution, because we have to have at least two things, we're going to have two parts to every solution. We're going to have a solvent and a solute, or multiple solutes. The solvent is just whatever we have the most of in the solution. That is the solvent. Again, we don't care what the molecule is. The vast majority of the time, our solvent is going to be water, but it doesn't have to be. That's the way things usually work out, because water is so good at dissolving stuff, which we'll talk about in just a minute. But it doesn't have to be water. Whatever we have the most of, that is our solvent. Whatever we have less of, that is our solute. And we can actually have more than one solute, but everything extra, everything that we have beyond the solvent, all the rest of those are solutes. We don't have a special name for one or another. It's just everything else is a solute. For our purposes, just because we're keeping things fairly simple in this chapter, we're only going to be dealing with a single solute, but it's very common to have multiple solutes in a sample. But just for our purposes, we'll stick with one. So solutions with water, where that's the solvent in the solution, are actually really prevalent, as I mentioned just a second ago. Because they're so prevalent, we actually have a special name for these kinds of solutions, and these are called aqueous solutions. I've heard a few people pronounce it aqueous solutions, and I've never actually heard someone say this is absolutely correct pronunciation. I've heard more people say aqueous than aqueous, and I think aqueous is easier to say, so I'm going to stick with that one. So aqueous solutions, these are solutions where the solvent is water. But we don't have to have water as our solvent, as I mentioned. We could have all sorts of different things as the solvent, and we could have things in different phases as solvent and solute as well. So, for example, what you're breathing right now, the atmosphere, that is actually a gaseous solution, where we have the solvent is a gas and the solutes are gases. Specifically, nitrogen is the solvent in the atmosphere, and oxygen and CO2 and argon and all the other stuff that's in the air is a solute. We can have liquid solutions where the solvent phase is liquid, and liquid is actually really good at dissolving lots of different things. Again, especially water, but not just water. You can have gases that go into the liquid phase, or they are dissolved, I should say, into the liquid phase. So club soda, or just really any pop that is carbonated, is an example of this. Those bubbles that are being formed when you pop open or you twist open your bottle of Coca-Cola or whatever it is, and you start to see those bubbles form, it's not actually a chemical reaction that's creating those bubbles. There's actually gaseous CO2 that is trapped under pressure in the bottle, and when you release the pressure, those gas molecules start to come together to form bubbles and escape. You can have liquid-liquid solutions, so any kind of booze, so vodka or rum or really anything like that, that would be a liquid-liquid solution where you have one liquid dissolved in another liquid. You can have solid liquid solutions. So if you take something like salt or sugar and you dissolve it into a liquid like water, that is also a solution, and that is a solid in liquid solution, because the molecules that are dissolved aren't actually in the liquid phase. It's not the same thing. You can make them go into the liquid phase. So you could take table salt, for example, and you could heat it up to where it was hot enough that it would become a liquid. But that is nothing like the salt being dissolved in water. Those are two very, very different situations. So a solid dissolved in liquid is another option for a solution, and one that is very rarely thought about but is actually true is you could have solid-solid solutions. So you could have a solid dissolved in another solid. Usually this is accomplished by melting it first. So like with alloys like brass, for example, and any other metallic alloy, you take the two metals and you melt them together to create a solution in the liquid phase, and then you just let it cool down to become a solid again. And it's still a solution at that point. Just because it became a solid doesn't mean that it's no longer a solution. It is still technically considered a solution. So lots of different kinds of solutions out there in the world that we interact with all the time. All the time. So, this little otter here is wondering, why do these solutions form in the first place? Why would two things, two different molecules, want to come together and mix? And there's actually two possible reasons for this. The first one is entropy, and we will talk about that in the next video. So I will see you all there.